Imagine enjoying a perfect day out on the water, only for your lights to flicker, your navigation system to cut out, or worse, your boat's engine to sputter because of an electrical problem. Often, the hidden culprit behind these frustrating issues is something surprisingly simple yet vitally important: the size of your electrical wiring. On a boat, wire gauge is crucial because it directly affects the safety, efficiency, and reliability of your entire electrical system. Using the correct wire gauge prevents dangerous overheating, minimizes power loss to your devices, and safeguards against potential electrical fires, ensuring everything from your bilge pump to your fish finder works exactly as it should. The core reason lies in how electricity flows through a conductor. Wire gauge refers to the thickness of the wire itself, and a thicker wire, indicated by a lower gauge number, has less electrical resistance. When electricity encounters resistance in a wire, it generates heat. If a wire is too thin for the amount of electrical current, it will generate excessive heat, which can melt insulation, damage electrical components, and even start a fire. Furthermore, too much resistance causes what is known as voltage drop, meaning that the device at the end of the wire receives less power than it needs to operate correctly. This can lead to dim lights, sluggish motors, and unreliable electronic equipment. To ensure you are using the right size wire, you will need to consider three main factors: the amount of current your device draws, which is typically measured in amperes, the total length of the wire run from the power source to the device and back again, and the acceptable amount of voltage drop for that particular circuit. Generally, marine industry standards, such as those set by the American Boat and Yacht Council, known as a BYC, recommend specific wire sizes based on these calculations. Always consult a marine wire gauge chart to match these three factors to the appropriate wire size, and when in doubt, it is always safer to choose a slightly larger, or lower numbered, gauge than what you calculate. It is also important to remember that marine environments are exceptionally harsh due to constant exposure to moisture, salt, and vibration. This is why marine-grade wire is not just ordinary electrical wire. It is typically made from tinned copper strands. This tinning process adds a protective layer against corrosion, which is a major enemy of electrical connections on a boat and can further increase resistance. Additionally, different circuits have different tolerance levels for voltage drop. For example, critical navigation and safety equipment might requiring a voltage drop of no more than 3%, while non-critical lighting circuits could tolerate up to 10%. By understanding and applying the principles of proper wire gauging, you are not just connecting wires. You are building a resilient, safe, and dependable electrical foundation for your vessel. This attention to detail will prevent costly repairs and frustrating breakdowns, ensuring you can confidently rely on your boat systems and fully enjoy every moment you spend on the water, knowing that your electrical power is flowing smoothly and safely.